Welcome to the 10th annual iRods User Group meeting. I'm delighted to have all of you here. My name is Jason Koposki. I'm the executive director of this little consortium of ours, and we're excited to be back in the United States for this user group. We would absolutely like to thank our sponsors. So our platinum sponsors are RENCI and Western Digital, and our gold sponsors of DDN and Quantum. We have 23 presentations from 5 different countries, which I think is a great collection here. So we're all delighted to have you. I'd like to invite Dr. Stan Ahalt to come give our keynote. Stan serves as the director of the Renaissance Computing Institute at UNC-Chapel Hill, and as the director, he leads a team of research scientists, software and network engineers, data science specialists, and visualization experts who work closely with the faculty, research teams at UNC, Duke, NC State, and partners across the country.
Thank you. I don't think I need this. I believe I might. Yes. And I'll go up here because I have some notes. And I brought something to show and tell. And I want to emphasize, just to take the pressure off myself, that this is a keynote, not really a keynote. And the reason I say that is I want to cover kind of a collection of things. And when I walked in the room this morning, it struck me kind of interestingly that the last time I was in this room, it was to give a talk on almost the same topic for DCRI. And this was about maybe a year ago. And so when I walked in, I kind of had a sense of deja vu that I'm talking about something that's progressed significantly since then. And that's one of the projects I'm going to talk to you about called Data Translator. And I have slides, but Terrell tells me that I just have too many words on my slides, so I'm just going to use my slides as notes and just chat with you. So first thing I want to say is welcome. I know a lot of you all came from very far away, and we much appreciate the fact that you're here. You're here in Durham, beautiful Durham. You couldn't have picked a better weather day. And in fact, it's a few days of beautiful weather, so it can get hot here in North Carolina, and you're going to avoid that apparently, which is not too bad. I also just want to say how much we appreciate you all being involved in the iRods community, because it really has taken on a life of its own. And the projects I'm going to talk to you about, while they're research projects, and specifically NIH research projects, they're also, in almost every case, based on the use of iRods. And I think it's extremely interesting, and not only by our team, but by other teams that are participating in these programs. So there's a really interesting story here to tell about how Regan, Raja, and some of the other folks started out with this idea of iRods, and it's now becoming part of a national infrastructure, and I want to tell you about that. So, you know, Renzi and iRods are closely intertwined. We also have recently gone through a strategic planning process, which you can go to our website and see very clearly where we are focused, and that is in the data science space. And data science is a rapidly emerging new discipline. I would argue that it will be only a short time before we have departments of data science cropping up at various institutions. We already have graduate programs in data science. Some of them teach the use of iRods in those projects, and we're seeing a new wave of doing science in very different ways. And that's kind of what I want to tell you about. So I want to tell you about these 4 projects, and then my observations about how those 4 projects are a precursor to what is to come, and how it's going to change the academy and higher education and probably science in general. So RENCI's mission is to develop and deploy data science cyber infrastructure. And we do that in order to help researchers in academia, government, and business use data to drive discoveries. We want to see faster rates of innovation. We want more informed decisions. And we also want to spur economic growth. Many of you all know, well, maybe not many, but some, that we're waiting to hear whether Google is going to locate its second headquarters in the Triangle. And we have certainly hopeful that that does occur, and what that will do to accelerate data science in the Triangle. RENCI is a very cross-disciplinary organization. We work with people from just about every discipline, including the humanities. And it has become very clear over the last 5 years that more and more of the work that we do at RENCI is focused on the use of data science for particular disciplinary work. But in almost every case, the secret to making that science go well is to have a very diverse, multidisciplinary team that you can bring to bear on the hard problems, because that's what we're faced with now in society, is very complex, hard problems, like global warming, like energy, like health. So these things are not problems that we can easily solve, and I would argue that we're transitioning out of a period where singleton scientists or small groups of scientists could do this type of work on their own, and now we necessarily need to have much stronger teams and be able to discipline the teams in order to stay focused and make progress on specific tasks. So the RENCI is really a service organization. We try to support other people doing their research, but in the process of doing that, we also do our own research, and we publish, and we write proposals, and we bring in grants. So we look much like a traditional disciplinary unit in higher ed, except for the fact that we build things, and we try to build them to last. And that's certainly characteristics of IRODS and the IRODS consortium. We provide support for IRODS, we pour money into it, and we use it at the same time, so it's a virtuous cycle. We believe in that model, but we also know that there's other models that exist, and certainly other software packages that exist that do some of the same things as IRODS, although I think I would argue that IRODS does has a breadth of capabilities that's unmatched in the marketplace right now. Now, with breadth comes complexity, and sometimes that's one of the things that you have to deal with, is making sure that that complexity is managed in such a way, or you have tools that allow you to use that complexity to your advantage and not to your confusion. And that is always the case with technology, that there's some challenges along with doing really cool stuff. You have to figure out how to do cool stuff. Now, I brought with me today, and this is what I spent last night doing, is making slides about a brand new NIH strategic plan for data science. And you can just Google that, and you can find that on your on the interweb. It's about 28 pages long, and it also has a glossary. And so what I did is I went through it last night asking myself, this was out for draft about 3 months ago. They report that they had 891 comments. I think I got that number right. 891 comments from the general community. So this reflects a lot of energy and work. And I just want to summarize that strategic plan and then roll into the discussion of 4 projects to see how this all fits together. So they make mention of the fact that, according to a survey that was conducted in 2016, data scientists across a wide array of fields, and I have not seen this study, but they said that they spent most of their working time, about 80% of their working time, doing what they least like to do, which is collecting existing data sets and organizing the data. Now, if I was an IRODS expert, I would think this is job security, because that's exactly what IRODS is designed to help you do, okay? So you all in this room are in a real sweet spot. You have the skills and the know-how to really help your organization, your institution, your company, because more and more being able to organize and collect disparate data sets is the name of the game. It is what is going to fuel future innovation. They also have in this strategic plan, the very first figure is a figure that startled me, frankly. And it's a figure that shows the growth of NCBI data services, the national, and this is basically the National Library of Medicine, supported by NCBI. NCBI is the National Center for Biomedical Informatics, I think, okay? And it shows a near exponential rise in both the number of genomes that are being collected on a yearly basis. And right now we're running at about 200 million sequences are being produced per year, okay? Or accessed and being utilized in science. That's a pretty startling number, but even more startling to me was the number of people that come to the website on a daily basis. Weekly basis is now up to about 4 million, okay? So if you think about this, NIH has resources, databases, okay, data collections. They're now being accessed 4 million times a week. And to conjure up what that means for science is pretty startling. It means that people are coming to these public resources and trying to infer what the next drug might be, or how to figure out how to treat a disease, or how does a model organism represent something similar in a pathway to a human. So these are complex, hard problems, and there's a lot of people in it. I guarantee these are not all in the United States. Okay, these are people and researchers from all across the world, and it's an impressive number. And as a consequence of looking at those two pieces of information, it's really hard to collect and organize data, and yet we need the data more and more. NIH has decided to make some decisions, and we have some NIH folks here in the room. Okay? In fact, we have probably 5 or 6 people from NIH in the room, at least, as a minimum. So they declared that this is a new era for biomedical research. Key topics that the report calls out are clinical data and information security. Keeping your data safe is critical. It is not easy. I spent probably 2 days in the last week talking about data access to sensitive data. Okay? The current data science challenges for NIH have been laid out very clearly. And interestingly, NIH has declared that they're going to hire a chief data strategist, and that strategist will work in collaboration with the NIH Scientific Data Council and the NIH Data Science Policy Council. So they're setting up governance structures that allow them to use their data in a more efficient and hopefully innovative ways. They have a list of pressing issues. Those include managing data as well as enabling scientists to individually generate data and put it back into the general source of data. They have a current data resource ecosystem that is siloed. They acknowledge the fact that many of the center and institutes have created really important, really expensive data sets that are unable to be shared, or they're only used by a limited number of people. They point out that there are important data sets that exist in many different formats, and that makes the sharing particularly difficult. And yesterday we had a couple of hours discussions on what is the right metadata level to put into one of our projects that I'll talk about in a minute. And they also mentioned the fact that the data resources, which typically means a collection of data that has some similarity or some thematic relationship, often use funding resources that are designed for research projects. And by making a data resource a research project, they observe that it has aligned or caused a misalignment of objectives and review expectations, because collecting data and putting it into a data collection is not necessarily a research project, although there's a lot of research issues to contend with. And so they're now looking at trying to find new funding models that permit them to be more interactive with the people that they ask to create these resources or ask to unsilo these resources. And they also noticed that the funding for the tool development and data resources have become entangled. So they're going to try to split these things apart and try to make a more methodical approach to building long-term hardened tools. And their final pressing issue that they point out is that there's no general system to transform or harden highly innovative algorithms and tools that are created by academic scientists into enterprise-ready resources. On my own campus, we made an effort some years back to create a data storage resource that allowed people to publish data. Okay? That we wanted people's data that's being created on the campus, and there's a lot of it, to be able to be found, and in fact, to be able to be fair. Okay? And many of you know what fair means, and now it's taken on its own life as a critical capability of most new collections. And what we found was there was very little interest among the faculty to do any such thing. Okay? And it really surprised me that people wouldn't want to put up their data and be proud. But over and over again, the answer was, why? I'm not incented to do that. Nobody's paid me to do it. Nobody's even asked me to do it. Sometimes people ask me for my data, but I just give them a USB key, okay, or whatever. I give them access to my pile. And so it was really a shock to me that as scientists, and I would include myself, hopefully in a younger version of myself, you spend your energy where it's going to pay off for you, and doing these things, putting up data resources because they have value beyond what you had originally imagined, is not something that's on your critical path, and as a consequence, it's really hard to overcome misapplied incentives. In some cases, the tenure incentives, because all we're really, told to do is teach, publish, and bring in money. And sharing data is not one of those items. So we have an interesting confluence of events in higher ed. And the NIH report goes on to talk about their overall goals and objectives. They have laid out a nice structure of data infrastructure, a modernized data ecosystem, data management, analytics, and tools. Very interestingly, workforce development, something that's being talked about on many campuses, including here at Duke, over at NCSU, and at UNC. There's very active discussions about how do we build a data science workforce or a data management workforce. And some of those institutions have world-renowned, certainly over at NCSU, the Professional Masters of Data Analytics is considered best of breed. So you're right in a place that is actively worrying about all this stuff. And it's interesting that NIH has called out so strongly all of these issues. And then finally, the interesting one from you all of these are interesting, but another interesting aspect is stewardship and sustainability is critically important. So, these are the areas, the pillars, if you will, of the NIH data science strategic plan. And then they have a number of cross-cutting themes that they mention, that, leveraging commercial tools, making public-private partnerships, creating organizations that, and communities around data so that the data gets more broadly used and curated, validated, et cetera. But, generally speaking, if you take a look at the strategic plan, you can see that NIH, which has always had a focus on data, is upping its game. Okay? And NIH is a very large funding organization in the United States, carries with it an imprimatur that us in academia pay attention to. And with that, I want to talk to you about, real quick, because I know I'm running out of time, 4 projects. And to me, these projects are all intertwined. I'm not sure they're intertwined in the mind of Francis Collins and NIH, but at least we're talking to NIH about how they're intertwined. The first is the data commons, okay? And the data commons, many of you all have heard about this, is an attempt to build a common platform, not necessarily using one single technology, but a common platform that allows data collections to be shared across NIH, okay? It's a new program. It's been underway for about 6 or 7 months. It's where I spend way more of my time than I should. But it's also a passion, because I think if we can do this, it's going to change biomedical informatics and change the science of healthcare. About 325 people, I estimate, are working on that project, and those are people in private industry, in academia, and also people at NIH. And it's the platform. And at least 2 of the projects, I believe there are, I carry around a little, if somebody asks me, I'll show it to you. But I carry around a little 2-sided sheet so I can keep track of all the players on this program, okay? And there's about 7 or 8 teams that have been formed. I'm not necessarily perfectly accurate here. And they range, all the way from coast to coast. And those teams have been brought together and then told to cooperate, okay? And there's the rub. It's an interesting socio-technical dynamic that I'll talk about a little bit more, and what I'm seeing happen there. So that's one of the projects that RENCI and iRods is working on. We also have another project that's closely associated with data commons, which is called Data Stage. By the way, both of these are called out in the NIH strategic plan as exemplars of the right thing to do. I hope that's true in the long run. It's the beginning of a 4 or 5 year project. That's an instantiated commons. It's basically NHLBI, the National Heart and Lung and Blood Institute, that is building its own full stack. That's the terminology they use to talk about all of the pieces that they need to be able to handle their data. And that is supposed to be the first instantiation of the data commons. And the idea is you build a platform, and then you put these, here's the platform, and you put these full stacks on them. And ultimately, NIH would like all of these things to be able to be, including the ones that have been built in the past, to be plugged into the data commons so that the data can interoperate across these what was formerly silos. Okay? At least this is my interpretation. I don't speak for the NIH at all. Then there's another project that is really amazing in the way it's been structured and the way it's turned out. It's called Data Translator. And Data Translator is an attempt of about 6 teams to wrap up data sources, which we call in that data translator parlance knowledge sources, in smart APIs, and then work on them collectively and build tools that allow us to take data from highly disparate sources and reason over that data. So data commons platform, data stage, an example of a particular full stack, data translator, the beginnings of how we interoperate across all of these data collections. And then finally, the fourth one, and Renzi and iRods is involved in all of these, is data reasoner. And it's an attempt to bring AI into the mix. Okay? How do we build knowledge graphs out of facts that we can derive, or factoids, I don't know what you want to, relationships that we have in data. So these four things fit together beautifully, and together they represent a really new, innovative way to do science. And NIH's thoughtfulness about putting these together is truly amazing to me, because they've managed to come to a collective decision that they're going to have to do science in a new way. It's not going to be a postdoc trying to figure out how the data works to get one paper out, and that takes them a year. We need to speed up that process dramatically. What we did in a year, in 2 years, I want to see us to be able to do in a week. And then 2 years after that, I'd like to be able to do it in an hour. Okay? So I want to shorten the amount of time it takes for people to mess around with the data to come to what I would call serendipitous moments of scientific discovery. We want to be able to find incredibly surprising new ways of looking at the universe. In this case, biomedical science, but in my mind, this is the beginning of a new internet of science, a new way of, instead of using our current internet to just do business and commerce, I see this as the blossoming of a new age of science, a new age of reasoning, where data drives things at a rate and a pace that we can't imagine right now. And 5 years from now, maybe I'll retire, but I want to look back and say, wow, we really made a difference. So just a few observations, and then I'll quit. Okay? First of all, team science is essential. We must figure out how to work together. We don't always have to cooperate, but we got to play nice. Okay? And there are many roles that have to be respected in a team science project, including project management, which is essential. There's no way that you can throw a bunch of high-powered Reagans into a room and expect them to suddenly make something magical happen and it actually be hardened and running and sustained for the long term. So you need DevOps, you need architects, you need documentarians, you need people who talk about principles, about how we're going to do the open science stuff and mean it, and ways of enforcing that you mean it. And so right now, the last week I spent my time, last 10 days I spent time creating an RFC process for the data commons. Okay? Here's how we're going to document what we plan to do, whether it's a standard or informational purposes or processes. We're going to write it down and allow everybody to comment on it. And it's going to be ratified after a period of time. So if you don't comment on it, tough. Okay? It's going to be still the law of the land. So we've figured out a loose organizational principle. The second thing I want to point out is it is clear to me now that you have to build for the machine. And by that I mean build so that AI can go across your data. This is scary business for some of us because we're not used to it. But it forces us to think about data in an organized fashion that means that it'll be much easier for humans to use too, but at the same time we need AI to be able to crawl over these very disparate data sets and find relationships that we would not be able to find with our slow but insightful brains. And let's use the AI to help us make that go faster. Okay? And then we, as a data science cyber infrastructure community, we have to insist that we're not going to build bespoke solutions to problems. We have to build things that work with, that interoperate. And that is a shift in our thinking. It's a shift in the way we go after funding. It's a shift in the way we conduct our science. But we have to insist on building things for the long term, building sustainable software tools like iRods that allow us to come together as a community and do something. I mean, 5 years ago, the number of people in this would have been in this room would have been How many? 40. Okay? We're growing, and I expect it to grow faster. And of course, not everybody who's using iRods is in this room by any stretch of the imagination. But you all represent, some people who get it. Okay? And that's important. And then my final observation, and I'll quit, is that we're at an inflection point. This quest is nothing less than the change of how we do science. And we have to respect that and be part of that cause, because we're on a quest that's noble and good. Hopefully it's all good science. And I think it's going to change the world, because we're going to be able to find facts and solve harder problems that we couldn't have imagined in the past, and we're going to be proud of it. With that, I'll take a few questions if we have any time left. Thank you. I can't see anything up here. It's a big glare.
Is this Mike? Yeah.
Thank you. David Wade, Integral Engineering. So this is an issue that came up in our organization in one of our discussions, and that is how data is valued. And in our conversation was involved with the recent Facebook mistake, which in our view, the mistake that Facebook makes is that they take my data in exchange for a service to me that isn't valued. So we argued that if I could post a photograph on Facebook and value it at $1, that Facebook could charge me a service fee for that, or by month, but then whoever wants my photo has to pay me $1. Well, relationship to data in general, I would think if you have a database that's being collected publicly, and you have 4 million users going out to get it, if you've got $1 for each access, you wouldn't need government funding, So the question is, our problem is that we've been asked to connect some of these systems to a financial system, because people running HPC want to know how much it costs per transaction. And it costs per, so I just wanted to know what comments, or if anyone in here wants to talk later on about this issue. I think it's a fascinating issue that isn't often discussed.
Yeah, I'll respond briefly to this idea of the value of data. If you go back and read Claude Shannon's work, and some of the other great thinkers that gave us information theory and in many ways, made these magical phones possible. It was a really interesting observation by, I think it was Claude Shannon, that basically information theory separates out the meaning from the bits. And it was a purposeful engineering decision to decide to not worry about what the bits mean, but instead just look at the randomness of the bits. And basically entropy in information theory looks at how random the data is, okay? And I, too, agree that we may not have the luxury anymore of evaluating data in terms of entropic information theory, and instead we perhaps need to find ways to value the data. I have a proposal in to NSF to create a workshop series to value data. Okay, and some organizations like NASA have done a very good job of explaining the value of their data. So for example, the weather satellites, you can calculate pretty accurately how much that data is worth. You also know how much it costs to get that data. But weather predictions, the risk management of shipping lanes, how much you charge for insurance at the shoreline, all of those things are driven, at least in part, a significant part, by weather satellite pictures. And so there's a real economic value, and they have calculated that, and they can show that there's a return on investment for collecting and curating and storing that data. We have not done the same thing. I mean, certainly Facebook, certainly Google, certainly Microsoft, the list goes on, have made a lot of money off of our data. In fact, there's been great cases of organizations. 23andMe, for example, apparently sold a collection of genomes that were quite unusual for a very large sum of money, in excess of $1 billion, okay? That's data. We paid them to give us our sequence, and then they turned around and sold it because that's the agreement we made. So somehow we've got to figure out how to value data so that we can understand the economic proposition. So I entirely agree with you. I think this is a really interesting topic, and one we could spend weeks talking about. And if Claude Shannon gave up on it, it's got to be hard. Anybody else? Well, if there's no other questions, thank you very much.
Thank you.
Thanks.